I did my research paper on a green laser pointer. There are three main components to a green laser pointer. One is the battery, two is the pump driver, and three is the laser module. The simplest of the three is the battery. The battery is responsible for providing power to the green laser pointer. In this example, two AAA batteries are used. The second is the pump driver. The driver in its resting state is an open circuit. When the button is pushed, the circuit becomes closed and power is allowed to flow from the battery to the laser module. Due to the second law of thermodynamics, energy from this power transfer is lost in the form of heat. In order to prevent overheating, the pump adds feedback in order to keep the drive current regulated. Power from the battery is immediately moved from the battery to the pump diode. The pump diode generates a beam of light at 808 nanometers. The light from the pump diode passes through this focusing lens to this NdYV04 crystal. The focusing lens acts like a magnifying glass, taking a lot of cluttered light from the pump diode and focusing it. Right here, the crystal adds constructive interference, making the wavelength of the light go from 808 nanometers to 1064 nanometers. The crystal is connected to what is called a frequency doubler. A frequency doubler does exactly what it sounds like. It doubles the frequency. As you can see in this crude drawing, light is entering the frequency doubler. Inside the frequency doubler, there are nonlinear crystals. When light hits the nonlinear crystals, it splits it up, causing constructive interference. In this drawing, I've taken one of the crystals and just exploded it just to make it easier to see. When light hits this crystal, it causes these wave fronts. So as you can see, this wave right here, it interferes with other waves, causing constructive interference. These little blue dots are the amplified waves. The light that leaves the frequency doubler has a wavelength that's been cut in half, but a frequency doubled. It is important that the new wavelength is halved to 532 because the human eye can only see a wavelength of 392 to 700 nanometers. At 532 nanometers, the light is visible to the human eye as green. The light from the frequency doubler then goes through the expanding lens. The expanding lens does the opposite of a magnifying glass. It takes the refined light and expands it. This light then goes to the collimating lens. Here I have a drawn picture of the collimating lens. So as you can see, light is entering at a bunch of different angles, and what the collimating lens does is it cuts down all these angles so that when they leave the collimating lens, they're all traveling in the same direction. After the light leaves the collimating lens, it passes through an infrared filter. The infrared filter filters out infrared light, and then the final product is a green light that you can see. Green laser pointers are a lot stronger than red laser pointers because the frequency is doubled. Green laser pointers require a lot more battery to function. A green laser pointer is a lot more complex than a red one. As you can see from this pump diode, if it were a red laser pointer, it would just immediately go from this pump diode to this infrared filter and be done with it. But since the frequency needs to be doubled to make green, you need all this extra components, which makes a green laser pointer a lot more complex.